Hello students, last time we had read the solution and the concentration of the solution. Now we are going to the new topic. The topic is mole fraction. First, how to define the mole fraction? Mole fraction is defined as the number of mole of any component out of total number of mole present in the solution is called mole fraction of that compound. So it is defined as the number of mole of any component out of total mole of the solution is called mole fraction of that compound. For example, suppose it is beaker and beaker is filled with the component A. Beaker is filled with the component A. Now we add the component B into the component A. Then the solution become homogeneous. Homogeneous means the component B are equally distributed throughout the solution. Clear? This solution is the binary solution because there are two components, component A and component B. Suppose the number of mole of component A is Na and the number of mole of component B is Nb, and the total number of mole present in the solution is Na plus Nb. So we are calculating the mole fraction of component A. Mole fraction of component A is equal to the number of mole of A out of total number of mole present in the solution, because the number of mole of component A present in the solution is Na and the total number of mole of component B present in the solution is Nb, and the total number of mole present in the solution is Na and Nb. Clear? So the out of total number of mole is Na plus Nb, and by using this formula we can calculate the mole fraction of component A. This is the mole fraction of component A. Na is the number of mole of component A and Nb is the number of mole of component B. Clear? Now we are calculating the mole fraction of component B. We are calculating the mole fraction of B. We are calculating the mole fraction of B So we have to put the value of number of mole of B out of total number of mole present in the solution. So Na plus Nb is the total number of mole present in the solution. And by using this formula, we can calculate the mole fraction of component B. Is the mole fraction of component B. Clear? Now, the important point is the sum of mole fraction. The important point is the sum of mole fraction of components is always equal to 1. It means that the mole fraction of component A plus the mole fraction of component B is equal to 1. The one question will be arise, how to calculate the number of mole of component A and component B. So we know that mole is equal to weight of solute divided by molecular weight. By using this formula, we can calculate the number of mole of component A and component B. This is the first question, which is based on the mole fraction. The question is, in a solution of 900 gram of H2O and 5.8 gram of acetone, find the mole fraction of H2O and acetone molecule in a solution. Suppose it is a beaker and it is the solution, and it is a solution of, according to the question, it is the solution of H2O and acetone and the formula of acetone is CH3COCH3. Clear? First, we are calculating the mole fraction of H2O. So we have to write the formula of mole fraction. The mole fraction of H2O is equal to the number of mole of H2O divided by the total number of mole present in the solution. That is the number of mole of H2O plus the number of mole of acetone. Clear? And if we are calculating the mole fraction of acetone is equal to the number of mole of acetone divided by total number of mole present in the solution, that is number of mole of H2O plus number of mole of acetone, and by using these two formula we can calculate the mole fraction of H2O and the mole fraction of acetone. First, we have to calculate the number of mole of water and the number of mole of acetone. We know that the mole is equal to weight upon molecular weight. Clear? First, we are going to calculate the number of mole of H2O. So, number of mole of H2O is equal to weight of water, that is 900 gram, divided by molecular weight of H2O. The molecular weight of H2O is 18. So, number of mole of H2O is equal to 50. Clear? And the number of mole of acetone is equal to weight of acetone, that is 5.8 divided by molecular weight of acetone, that is 58, and number of mole of acetone is equal to 0.1. Clear? Now we have to put the value of number of mole of H2O and the number of mole of acetone in this formula. Clear? So first, mole fraction of H2O. Mole fraction of H2O is equal to number of mole of H2O is 50 divided by total number of mole present in the solution, that is number of mole of H2O 50 plus number of mole of acetone, that is 0.1, and the mole fraction of H2O will be 0.998. And we are calculating the mole fraction of acetone is equal to the number of mole of acetone divided by total number of mole present in the solution, that is the number of mole of water plus number of mole of acetone. Clear? We are putting the value of number of mole of acetone and water, that is the mole fraction of acetone is equal to number of mole of acetone. Number of mole, that is 0.1 divided by total number of mole present in the solution. It means 50 plus 0.1. The mole fraction of acetone will be 0.002. This is the answer. And clear?